In this video of Florida Man Math, we're answering another request from the r/learnmath subreddit. Question reads, for polynomial function f of x, the function g of x is defined as x raised to the 2f of x, so that f of x is in the exponent. So if the function g of x has a local minimum of 27 at x equals 3, what is the value of f prime of 3? Now, by itself, we don't have much information to go on, but the hint here is that g of x has a local minimum value of 27 at x equals 3. So that tells us that whatever g looks like, it's going to have a zero slope at a local minimum, and in particular at this value x equals 3. So it'd probably be really helpful to have g prime of x. So let's find that. So what we're labeling as g prime of x more formally should be written as d dx operating on g of x. And so this is equal to d dx operating on whatever g of x is defined to be. So let's just grab this, x raised to the 2f of x. Now by itself, this is kind of an unusual derivative because we're used to having just powers up here, or we're used to having polynomials or trig or logarithms or exponents. But here we've got an unknown function f of x, and we're asked to find the f prime at 3. So what we're going to do is employ a trick about basically inverse functions canceling each other out. What I mean by that is e raised to the ln of anything is just whatever the thing in the ln part was. So in this particular case, we're going to take e and immediately undo it by taking ln of this target function. So this is x raised to the 2f of x. So the exponents are getting quite stacked here, but it's okay because we're about to employ some log laws. So first notice that 2f of x is the entire exponent of the base x. So using logarithm laws, we can bring this out as a coefficient and get d dx of e to the 2f of x times ln of x. And this looks a lot better because now we can just take the derivative of e and its proper exponent using the chain rule. So what we have here is copy and paste the entire thing of e. So this is 2f of x times ln of x times the derivative of the proper exponent. So this is just the entire exponent here. 2f of x times ln of x. So this is nice because this breaks down to just a product rule, and the 2 can come through, because it's a constant, can pass through the d dx operator. So what we're left with is e to the 2f of x times ln of x times 2, and then we'll apply the product rule here. So first, f of x times derivative of the second, which is 1 over x, plus the second, which is ln of x, times derivative of the first. Now, we don't know anything about f, so we'll just have f prime here. All right, let's clean this up a little. Let's observe that this e to the 2f of x ln of x is really actually the original function, because we can write it like this. E to the ln, and again that base stays the same, raised to the entire coefficient, so to speak, of the ln. And now this piece can get cleaned up a little bit. Maybe something like 1 over x, f of x plus ln of x, f prime of x. And finally, the fact that e and ln cancel out like we intended to way up there leaves us with our original function times all of this. So what we can do is just put the constant 2 out here and then multiply all of this part out. And so the important part is to recognize that we still have this term f of x and also f prime of x. And the whole point of this was to get what we're labeling as g prime of x. So that's a useful checkpoint. So let's put that in a box for future reference. All right, so what was the point of finding g prime of x? If we go back to the original question, it says that g of x has a local minimum value of 27 at x equals 3. So this means that local minimum tells us this x equals 3 is a critical point. That's another way of saying that g prime of 3 equals 0. So if we set this entire thing equal to 0 at x equals 3, then we get a little closer to finding f prime of 3. So we'll take 2 times 3 to the 2 f of 3, all times 1 over 3 f of 3 plus ln of 3 f prime of 3. And this whole thing is being set equal to 0 because we know that x equals 3 is a derivative, critical point. So notice that this term is exactly g of 3, which it told us it has a value of 27. So that means we have 2 times 27 times all of this here equals 0, but we can just divide out 2 times 27, and so we just get all of this in these square brackets equal to 0. So we have 1/3 f of 3 plus ln of 3 times f prime of 3 equals 0. And so it would be really nice to know what f of 3 is, because then we could just get f prime of 3 by itself. But let's think back to, we know that g of 3 is equal to 3 raised to the 2 f of 3. And this is also equal to 27. So that is to say 3 to the 2 f of 3 is equal to 27 as a power of 3 is 3 cubed. So by taking log base 3 of both sides, we're effectively just dropping the base, and both of these fall to the floor. 2f of 3 is equal to 3. And so therefore f of 3 is equal to 3 halves, or 1.5. So plugging that value in, this means that 1/3 times 3 halves plus ln of 3 times f prime of 3 equals 0. These cancel out, and we get 1/2 plus ln of 3 times f prime of 3 equals 0. So getting f prime of 3 by itself is really straightforward now. We just subtract the 1/2 to both sides. So we get ln of 3 times f prime of 3 is equal to negative 1/2. And then simply divide by the constant ln of 3. So altogether, we can arrive at our final answer here. F prime of 3 is equal to negative 1 over 2 ln of 3. All right. If you like this video and would like some more like it, please like and subscribe. And as always, thank you for watching.